Hi everyone, welcome back. Looking at these tricky cases. What's what happens with students? They say, I'm comfortable with the sine rule, I'm comfortable with the cosine rule, and then you walk into a test and they say, that was different to what we did in class. So here we go, a couple of the ones that are different. This is the go-to, nice, simple one that mucks people up and stops them from getting the question right, even though they think they know what they're doing. Well, they do know what they're doing, but this throws them off. This triangle here, I talk about the three sides with a cosine rule. And so we can look at the two pairs with the sine rule or the three sides with the cosine rule. Depending on the way your brain works and what you think, you might start looking at the sine rule. But let's look at the three sides. If you use the three sides thinking, you have to know this angle there, because you need the angle opposite the side you're looking for. So you can't do the cosine rule. So we go back to the cosine rule, c squared equals a squared plus b squared, 2ab cos capital C. These are just little ab, they're the sides. This is the angle and the side opposite. So I need that angle to get that. Now this one's really obvious because 50 and 70, this one has to be 60 degrees. So it's really a little bit of a just trick people that they don't realise or they don't think of the angle sum of a triangle. I'm not going to finish the question off, but if you do and you want to go through and check it at 4.608, if it was metres, you'd have metres, and that's the 3 decimal places. So look at case number 2. It's actually, the interesting part is it's almost identical to case number 1. Most students will figure this out. Most students will get that wrong. Very, very common for students to get this one wrong. It's the same problem. I've got this side, I've got this side, we're looking for this side, so we have three sides. It looks like it's a cosine question, but it's not, because we don't know this angle over here. We don't know that one there. So, we knew that this one was 50, so on this one we have to figure out what that angle is. And that's where it looks like a cosine question, but it turns out to be a sine question. Now I don't want to clutter my diagram too much, but there's one pair there, and there's the other pair there. So there's my two pairs I keep talking about. Two pairs, so it looks like a cosine question, but it turns out that you need first of all to do a sine. I'm going to look at that in a fairly quick way. I'm going to look at this pair here. That will be 8 over sine theta, whereas this one will be 10 over sine 75. And you could put that in your class pad calculator instead of writing theta. You could put in your class pad calculator and put x and say execute, and it will give you the answer, but the annoying part will give you the constant and it'll give you two answers. Basically it's giving you an infinite number of possibilities. So this is the ambiguous case of the sine rule. So it is annoying to get it. I'm going to do it as if, because a lot of the people watching will not have a class pad, they'll have scientific. So I talk about cross multiply. So let's go back to making a theta for now. So if I multiply those two together there, because I want the theta, that's 10 sine theta. This is called cross multiply, if you haven't seen me talk about before. And that one cross multiply. If you wanted to talk about cross multiply, you could look at things like 2 over 3 equals 4 over 6. Any doubt in your mind that 2/3 is the same as 4/6? 2 times 6 is 12, 3 times 4 is 12. So you can go any order you want. 4 times 3 is 12, 6 times 2 is 12. We can make them others. Let's go 3/4 and 6/8. 3 8s are 24, 6 4s are 24. We can try to trick people. 2 is 4 on 2. But really that 2 is a 2 on 1. So as long as it's one fraction on the left hand side, one fraction on the right hand side, you can do this cross multiplication. That's 2 2s are 4 and 4 1s are 4. It will work. The moment you have something else, it's completely different. It doesn't work. So let me get rid of those. Cross multiplication. So it's a numerator times the denominator, and then it's a numerator times the other denominator. And you can go any order you want. So I'm going to go that pair first, that pair second. Then we're ready to go. If I divide this side by 10, because that 10 is controlled by a multiplier, and the opposite of multiply, the opposites to both sides, the opposite of multiply by 10 is divide by 10. Some people like to write a little divide by 10. Can I tell you, well I've seen over many years, writing it that way, it's one thing, it's quicker, it's probably more efficient, and the people I see write it this way make less mistakes than the people who write little divide. especially when the questions get harder. So if I divide this side by 10, I divide that side by 10. I've written all my numbers up here. So sine theta, when you put that into your calculator, is 0.77274. Then, to get the angle, you should have seen me say probably a lot of times, you can go, some calculators you press shift, then the sine button to get the angle. Or some calculators have second function or second F, press that, sine button, and then angle. And then if it's a class pad, you can go that one, which is a sine inverse button, but you could have done the question back here anyway. So let's say we've done that one there, the angle, well, there's two possibilities. Some of your calculators will say 50.6 degrees, and some of your calculators will have 229.4 degrees, and your class pad, if you look across and you scroll across, it'll have both answers amongst the numbers somewhere. What's the relationship between those two? If you know that this angle is obviously less than 90 and you get 129.4, subtract it from 180 and get the other angle. It's the ambiguous case for the sine rule, the one that drives everyone crazy. So I'm going to look at this 50.6. So now instead of that theta, I'll have 50.6. And now it's as easy as this question over here. We know the two angles here, we want this angle opposite. So over here I've got my calculation, 180 minus the 75 minus the 50.6, and you get 54.4. Saves me thinking and speeds up my video. I really try to keep these as short as I possibly can. Now if you look at that triangle, we've got the three sides and you've got this pair here. So we can go ahead and do the cosine rule. By the way, if you wanted to, you can go sine rule, which is just as easy to do. So I'm going to treat it as the cosine rule. So here's the important pair, so I'm going to call that capital C and little c. So these will be little a and little b. So we don't need to talk about these angles now that we know the 54. If you want to, you can use them, but let's just deal with this as a cosine rule. So now we'll have c squared equals a squared plus b squared, 2ab cos capital C. So little c is x with a squared, then we've got a 10 with a squared, 8 with a squared. For anyone who's getting comfortable, you might notice that these two sides are those two, which is those two there. And then cosine of, and our c was 54.4. Then you can pop it in the calculator and you can find out that it's 8.42. And if it was in metres, you would put it as metres. In this case, I've done it to 2 decimal places. So just watch the trick. This one is easy as that, but it's just got an extra step involved. I'm enjoying this. I hope you're enjoying this. If you are, spread the word. And if you really want to, press the subscribe. It's nice. I keep track of the subscribes. It's nice seeing them go up. Thank you for watching, and I'll see you next time.